Okay, so I added a few things to this. First off would be the algebra. So if you feel like your algebra skills are not sufficiently solid, what you can, I would recommend that you work through some problems in this text. So where is that? I put it here. Okay, there we go. Yeah. So what's useful about this textbook is that the practice problems are kind of challenging. So you can, the one in particular would be, where is it? Complex fractions here. So if the internet works, why is my internet? Something's.
Where is this textbook at?
You can just search for the guy's name, Tyler Wallace Algebra. The URL is right here. I'll paste it into chat.
Okay, thanks.
Yeah, and also I wrote like a little handout, I guess, for trig. So the unit circle, if you have some difficulty remembering that, that's the other thing I just sent. So, all right, so let me just point out, like, see, these are pretty complicated, but it's good practice for you. If you get used to these kind of complicated things, you'll be fine with the easier stuff that we actually require for like some of the problems that we actually do. And also beneficial is that the book actually comes with worked out solutions. So I don't know where the corresponding thing is. Where did it go? There. But yeah, you can see like it actually gives a few of the steps, so you can kind of figure out if you messed up somewhere, you can kind of trace back wherever you may have messed up. The unit circle stuff, I want to say a few words about that. Where are those posted? What do you mean? I just sent the links. Okay, well, it's the same second. It's okay. Right. So so this table you definitely should be familiar with. This is the evaluations of these trig functions on like the first quadrant. So 30 degrees, 45, 60, you should be familiar with these. And the patterns are, you see that the numerator is increasing. You see that the row for sine and the row for cosine are reverses of each other. And for tangent, the way I see this is you multiply by √3. So going from here to here, multiply by √3. Going here to here, multiply by √3. Another way is you could remember that tangent is sine over cosine, so you can divide, and you would get the row for tangent that way. The next two pieces, this one and this one, are for in case you get an angle that isn't in the first quadrant. So this, you can kind of extend things to other quadrants so long as you understand like what is a reference angle. And these pictures kind of describe what that is. So you use the idea of the reference angle and also what whether the trig function is positive or negative in that specific quadrant. That piecing all that together, you can actually reconstruct the whole unit circle, or all the evaluations on all the points on the unit circle. The very last thing is actually this, right? And that is because of these two columns, the 0 and 90 degrees. So it's helpful to remember that cosine is projecting onto the x-axis and sine is projecting onto the y-axis. So then the angle 0 is over here, and then you can see that the cosine is equal to 1 and sine is equal to 0, giving you these two. And then at 90 degrees, you're over here, sine is equal to 1, cosine is equal to 0, so that gives you those two. But I always forget this, so it's like it's not the default way I remember that. The default way I remember that is by visually seeing what does sine look like, what does cosine look like, as those squiggles, and so that's how I would figure out those. But this, I think, is the way you're supposed to, or is one way to remember it at least. Okay, so with that, like unit circle should be okay. Hopefully you don't have any difficulties. Any questions so far? No? Okay. Then let's start by fixing the mistake I made. I think I made 2 mistakes. Well, for the other section, I made 2 mistakes. For this one, I sort of caught myself. There is one thing I can do about this, though. There's something. Did I not draw the picture? Oh, you erased the picture. This is not the nicest way you can represent the answer. So I'm going to show you the nicest thing you can do. So you have these 2 points satisfying cosine of theta equals 0, right? And you know that is theta is equal to pi over 2 and 3 pi over 2. And I told you that you could do plus 2 pi k to it because you can wrap around the circle multiple times. If you actually noticed that you can get from this angle to that by just rotating by 90 degrees, or not 180 degrees, rotating by pi, you can actually combine these 2 families into one family. So the better thing would have been if I had seen that this is equal to pi over 2 plus pi k, because then I don't have to deal with 2 infinite families. I just deal with 1 infinite family. And then that kind of hints at the fact that you can combine these 2 together. Okay, which you could figure out if you actually listed out the numbers. So I did that and I realized that you can combine. So if we list out these the things in this expression, just like take k equals 0, take k equals 1, 2, just plug in, and then you end up getting negative pi over 6, 3 pi over 6. Wait, so 3 or 1, 3 plus 4 plus 4, yeah. 7 pi over 6. For this one, you would get pi over 6, 5 pi over 6, and 9 pi over 6. Combining this, so you see like got minus 1, 1, 3, 5. This is not 4, this is 7. Why did I make that look like that? 3, 5, 7, 9. So you get all the odd numbers in front. So the actual answer you should get from all this work is you can write the whole family of solutions as being an odd number times pi all over 6. So k is an integer. And so this would be your solution. Make that look like a pi. And I hope like you guys recognize that this expression is just saying that you have an odd number here. This is the mathematical way of writing odd number. Okay. Everyone happy with that? Then the next thing is correcting this. So I messed up because I was going too fast. And you do have to count correctly when you're drawing a parabola. So when you go over by 1, you go down by 1, or up or down, but that's because it's 1 squared, right? But when you go over by 2, you should go up or down by 4, and I didn't do that so much. So 1, 2, 3, 4 will land me right here, and it will land me 1, 2, 3, 4 right here. And I think this is an open circle because this is a strict inequality. All right, so now we just make it look like a parabola. And now we have this connected. Okay. And so because for these things, we actually read off of the graph, there are some changes that happen. So approaching 2 from the positive side is going to change. We'll end up getting 1. From the negative side, we'll get 0. Does not exist is the same. Does not exist is the same. 5 is the same. This one, so we're approaching 2 from the left-hand side, and this now has changed, and so we get 1. This stays the same, and this changes because now both of the side limits are equal to one another, which means that the 2-sided limit is the same value as those 2. This one changes because the filled in point has moved. So it's now 1, and then everything else is, the last one is fine. Okay. Questions so far?
Do you think you could go back to 8 just real quick?
8. Yeah, sure. Something specific about it?
No, I think I got it. Thanks. I just wanted to look at it.
Yeah.
Thanks.
Yeah. There's too many different ways you can just draw this. It's only just making sure you satisfy these 5 facts. So, yeah. Other questions? Okay. Then let's do today's material. And it's very likely that we will finish early, just because there's not that much to do now. So for this part, or for this problem, the idea should be, I think, to use all the limit properties that were shown to you in the slides. So the facts that are that, like, you can split the limit over the addition, you can pull the 2 out, you can split it over division and multiplication, you can push it into the square root. So you move that limit around until you get to a point where you actually can evaluate it. And this is because you're not supposed to just directly plug in. You're not supposed to just be able to say, like, plug 3 into these things. Until we get to continuity, which I think is like next week. So let's go ahead and do the limit properties. So we split the limit over the addition, and then I'll do that, and I'll also at the same time pull the 2 out. So that will give me this plus 2 limit x approaches 3 of g of x. Okay. And now this is given to us, it's 7. And this other piece is given to us is 9. So we can just plug those things in. And then we get 7 plus 18, which is 25. Okay. For part B, we do the splitting again. So we can split the limit around the division, and then we'll split it across the multiplication, and technically we're sort of splitting it over the addition as well. So when you fully expand it out, this is what you get: limit times limit divided by limit. And this is kind of the ridiculous one. Like, why would you write that? You know what it is. But technically, to be right, I guess you should. Yeah. Okay. And then there are various limit laws. So the first 2 are given, right? But then this one is a different limit law, where it says, like, the limit of a constant function is that constant. So this limit evaluates the 2. Now, this guy is sort of like a primitive. You know that, like, if you're taking x approaches 3 and you're just saying, what is x going to approach? It's like a tautology. You're repeating yourself. It becomes 3. So evaluating all this, 7 times 9, 2 plus 3, you get 63 over 5. Okay. For C, we well, we can pull the 4 out, and then we can push limit through a square root. In fact, we can push it through any exponent. So this will become square root of a limit x approaches 3 f of x plus limit as x approaches 3 of g of x. So equals that. And then we can plug in, because we have those given to us. So 4 times the square root of 7 plus 9. And so this is 16, 4 times 4, which ends up being 16. A little bit convenient. All right. Any questions on this problem? Hopefully that made sense. Yeah. Okay. The next few have to do with finding the average velocity and then from there finding the instantaneous velocity. So you should remember how you set up the average velocity. So it's the distance, change in distance over change in time. So, and one thing I might want to do is I might want to illustrate how is the time changing. So we start at time 2 and then we end up at time t. And so this is kind of a number line. And the expression that will compute for us the average velocity is going to be s of t minus s of 2 over t minus 2. And now we just simply plug things in. So s of t is going to be t squared. S of 2 is going to be 4 over t minus 2. Okay. Now, hopefully it's immediately clear that this simplifies. But I had to ask the other recitation. So let me ask you guys, what does this become?
Is it you're talking the t squared minus 4?
I'm talking the whole fraction. You can simplify the whole fraction.
Oh, well, it would be t on the top, it'd be t minus 2 and t plus 2. But the t minus 2 and the t minus 2 can cancel out, so it'd just be t plus 2, right?
Yeah, good. Yeah, you're explaining every step. That's right. That's fine. Yes. So yes, the end result you get is you get the t plus 2. And the reasoning is this guy factorizes. This is a difference of squares, a very common pattern that you see in algebra. So totally right. This factorizes as t minus 2 times t plus 2. And then you see that you can cancel the t minus 2's on top and bottom. The end result is this t plus 2. Okay. And I want to put units down because units are given. So feet per second. All right. So this is the expression for the average velocity of this object. And now we want to find the instantaneous velocity. So the connection between the two things is the instantaneous velocity is what happens when you let this endpoint approach, well, the two endpoints approach one another in some way. So, but in particular, this one, we want to make the t approach 2. So we say that it's the limit, and we still have this being the expression for average velocity. So we're going to use that, but we're going to make t approach 2 of this expression. Okay, well, let's not redo all our work. We know what this simplifies to, t plus 2. So we just put limit down. And the fraction becomes t plus 2. And we can certainly evaluate this limit. It's just 4. And we put units at the end. Oops. Okay. That wasn't so bad. The other two are also using just trying to make sure that you know the other algebraic techniques for simplifying or for evaluating these kinds of limits. So average velocity for this, first of all, let's draw a little sketch. Starting time is 1, ending time is t, and average velocity is going to be s of t minus s of 1 over, that doesn't look like a 1. Over t minus 1 is equal to, and now I plug into the function given. So s of t is going to become 1 over t minus 1 over t minus 1. Okay. Now what should I do from here? Any suggestions? Do you like the format of this? No one's saying anything. Well, I'll say that I don't like the format of this because it's got a fraction in a fraction. And if I see a fraction in a fraction, I kind of want to simplify it. Okay, this is what's called a complex fraction. It's the section in the online textbook that I showed you guys. So what we can do is we can get rid of that denominator. And the trick is to multiply it by something that will cancel the denominator, which is actually just going to be t. So if I multiply top and bottom by t, I haven't done anything, right? Multiply top and bottom by t is just multiplying by the number 1. Next, I distribute this instead, and that will simplify the numerator. The numerator is going to become 1 minus t, and I'm just going to leave the denominator the same. Okay. Now, there's another simplification that you can see here. Well, maybe you can see here. So how does 1 minus t relate to t minus 1? Anybody?
Would it be, oh, you got it, Dakota.
I was gonna say they're not are they considered inverse, or do I have that wrong?
Inverse is sort of the right word, but sort of not. When we think of inverse, we usually think of the multiplicative inverse, but it is a type of inverse. There's an easier word than that. Try finding a different word for what you're talking about.
I'm not entirely sure that I have the other word for it memorized.
Reciprocal?
No, you do. It's negative. It's the negative. It's easier than inverse. Okay. 1 minus t, take the negative of that, is equal to t minus 1. Okay. What I was saying is when you think of inverse, or at least when I think of inverse, I think of the negative in the exponent. Okay, like I think of a reciprocal of flipping the thing. So this is just the additive version of what you're saying. So there's a cancellation here where it introduces a minus 1. And then so you end up getting this guy. Okay. And this is the simplest form that you can get it. Feet per second. Okay. All right. So now we got something that looks nice. It's not as complicated as what we originally started with. All right. And this is kind of a trick that you should maybe familiarize yourself with. Like if you have one thing minus the other and you flip the two, that's just multiplying by -1. It's a little algebraic trick. Okay. So we got that. Now we want to compute the instantaneous velocity from this. So it's the same as before. We are taking a limit. We want to make that t approach 1. So we make t approach 1. We're talking about the average velocity thing. I'll just put like normal ones. Okay, and we don't want to redo our work. We just want to use it. So we have -1 over t. And certainly we can write down what that limit evaluates to, -1, and put down our units. Okay. So that should make sense, right? Now, I think we're going quite early then. So the last problem here is we have the square root. And this is going to show you the last, I guess, algebraic technique that you guys learned. So the average, oh, and here the time is a little bit different. It goes from 4 to 4 plus h. But we can still handle that. So we use the final time minus initial time. 4 plus h minus s of 4 all over. And then if I want to spell it out, I would write 4 plus h minus 4. But obviously this simplifies. Right? Let's go ahead now and plug in. So I'm just So what this means is that you plug the 4 plus h into the function that the way that s is defined. So we end up getting square root of 4 plus h. And then s of 4, we plug into the square root, we get 2. And the denominator becomes h. Okay. Now, if you've practiced these kinds of problems a bit, you immediately want to do something to this, because you don't really want it like that. You kind of can expect that something's going to go wrong if we try taking the limit for the next part. So what's the algebraic thing I can do to this?
Is it using conjugate?
That's right. Multiply by the conjugate. That's right. Yeah. So just like as a little thinking ahead, right? For the part B, we're going to want to take the limit as h goes to 0. And you see right away, if we let h go to 0, you're going to end up dividing by 0. You really don't want to do that. So typically, if I have the space, I would actually do the multiply by the conjugate over here rather than over here. And it depends on how you want to like arrange your work, I guess. Oh, but I should probably also show all the little details of multiplying the conjugate until you guys get used to it. So the conjugate is just you flip the sign between the things. So 4 plus h minus or plus 2. And you can't just arbitrarily multiply by something out of nowhere. You have to, the only number you can multiply by is 1. Right? You can't change your expression. So what we need to do is multiply by a fancy version of the number 1, which in this case is just going to be that conjugate all over again. So now that we have this, you can think about how you would distribute these things across, right? It's sort of a foiling thing, but it's also sort of, let me write down. It's sort of this, it's related to x minus a, x plus a equals x squared minus a squared. It's related to the factorization, this difference of squares. See, like if I put a square root, give myself a little bit more space. If I put a square root around x, I didn't give myself enough space. But what this is saying is that like, if you multiply by the conjugate, you end up being able to square that square root away and squaring that other number as a result. So there's a shortcut of doing this multiplying by a conjugate and expanding it out, where you don't even think about expanding it, just think about squaring away the square root. And what you get is this 4 plus h minus 4 on top, and then h square root of 4 plus h plus 2, like that. Okay. So, and maybe it makes more sense to put it at the bottom now, because I'm seeing like you should simplify this like twice. Oh well. Does that step make sense so far? Did I lose anybody? No? Okay. So the next thing I would see is that we have a 4 and a minus 4, and those cancel each other. And then I would also see that you have an h and an h that cancel each other. What I'm going to do, though, is rewrite this, because I know that some people will make mistakes on this step. So I'm going to rewrite this. And then we have a cancellation here and here. And this is because you can divide top and bottom by h. And so you're left with 1 over the square root of 4 plus h plus 2. So this is the simplest thing that you could transform this into. And I may as well put units. They are feet per second, feet per second. And now we handle the part B. So V, the instantaneous velocity. Well, it's going to be the limit of the average velocity. We let this go to 4. So in order to do that, we let h go to 0. So this is a limit as h goes to 0 of the expression above. And let's just put that as h. We know that as h. Okay, and we don't want to redo work, so we're just going to use it. We end up getting this 1 over the square root of 4 plus h plus 2. Okay, and this is really nice because we can just plug in. And we get 1 over 2 plus 2, 1 over 4, and the units are feet per second. Okay. So any questions on that? Any questions on anything else?
I had a question over, oh, let me find it. It was from the last time we were in class.
Yeah.
Okay, so it was over question number 2.
Number 2. Okay, let's see.
Yeah. So you had your dollar amount as $6, and you had your you had your X as 6 for $6, and then you had your Y
Oh, did I
for
miss that?
100.
Oh, yeah, I messed it up. Yes.
Yeah, I was gonna say it said C of P, and then I was like, yeah, I was
Yeah.
confused, but
Thank you for catching that. That's
yeah.
I wasn't very awake when I did the problem set. So the way you should think about this, right, is you make like maybe a graph sort of thing, and then you realize, oh, P is supposed to be the X coordinate. And so you're right. It's supposed to be 100 comma 100 comma 6. There you go. And then you can still do the point slope form. And so if we fix that, didn't notice that. I wonder if I did that on the other minus 100. And so then this is going to be a plus 6. This is a minus 100 plus 6. Yeah. Yeah. So that fixes it. Yeah.
Yeah, that looks
Okay.
right.
Yeah. Make sure I didn't. Maybe I misled them as well. No, I didn't. Oh, you guys are just unlucky. Okay. Any other questions, comments? If not, then we can end it early today. So. No, okay. Then I'm gonna stop the recording. Comment.